All right, we're going to take a look at triangle congruence, which we just got done in the last video talking about basic congruence. Remember the basic definition. The corresponding sides all have to be congruent. The corresponding angles all have to be congruent. That's a lot of work. That's 6 different sets of items that you would have to verify are congruent before we would satisfy the definition of congruence. But triangles are a very special kind of shape. Triangles, sometimes we can get away with what's called shortcuts. All right. Here's a quick little way of looking at that idea. Here's 3 different measurements, and I've got those same 3 measurements here. If we were in class, I would say, hey, you guys get as creative as you can. And these pieces, they snap together, and I would say, hey, make the funkiest triangle that you could make using those 3 measurements. All right. And so you might make something like this. And then I would encourage you, let's try and be way more creative. Maybe I attach the purple one over here, and then I got to put the green one in between like that. So let's see how different this triangle, because all I gave you was 3 sides. I didn't tell you anything about the angles. Do we have 2 different triangles? Turns out that you couldn't have made a different shape. If the 3 sides of your triangle are the same as the 3 sides of my triangle, it's impossible to end up with 2 different triangles. They will be congruent, which means I didn't have to investigate the angles. All right. So, and some people in my class occasionally say, come on, that's obvious, coach. You can't make 2 different triangles. Well, the mathematical world kind of agrees with those kids. That we're going to look at 2 shortcuts here today. One of them is generally referred to as SSS. It is the side postulate. So remember, postulate is some sort of an idea where we're kind of saying, hey, this is a little bit obvious. We're not going to argue about that, but just like we just proved with these are actually called angle legs. We proved here that if you and I both have the same set of sides, we don't have to know anything about the angles. So basically says if I have a triangle where the 3 sets of sides are all congruent, I do not need to investigate the angles. So this is a shortcut, the side postulate. Okay. Now the rest of them aren't as obvious, but there are technically 5 shortcuts. We're only going to take a look at 2. All right. The next one is called SAS. Stands for the side angle side. This is a theorem, so this one's a little bit less obvious, but can be proven. All right, so I'm just going to take 2 random triangles. And if I happen to have 2 sides, let's say I go for the outside side and this one inside. If I knew these 2 sides are the same. Now you got to be careful. Does everybody see this A that stands for angle is in between the 2 S's? That's called the included angle, which means if we're going to use this shortcut, I would need to know the angle in between the sides is congruent. So if we're just looking at one of these triangles, the angle in between is not the two down at the here. The angle in between would be right here. If I knew that this angle was congruent to this one, in each triangle I now have side, angle, side. If this much I know, then I am guaranteed congruent triangles. Okay? These are 2 of the 5 shortcuts. So here's how this might look on a test. Here's an example, and I want to give you kind of some hints on how to look at this. Let's say we were looking at this situation here. Each time you'll be given a diagram, you will most likely have labels on all of the points, and you might even be given some information. All right? If you want to be successful at these problems, I recommend a procedure. Step 1, make sure you take a look. What is currently congruent? You want to make sure and take note that in each of the triangles, I have currently not just one side, but I have a second side that's been marked congruent. Step 2, should anything else be marked congruent? Here's where you're going to get yourself in trouble. Because you may look at this and go, everything looks great. Look at these angles. They look the same. But we need to have rock solid ideas. And I'm just going to give you a hint. You should only be really looking for 2 things. There's more stuff out there, but if you just look for these 2 ideas, you can get an A on my test. 1, you need to be looking for what I call reflexive sides. A reflexive side, we talked about the reflexive property. Remember, the reflexive property says something equals itself. Well, here's an example of reflexive sides. If you see that in the triangle on the top has segment AH. The triangle on the bottom also has segment AH. Those have to be congruent because of the reflexive property. Which means, be careful, I've already used 1 mark, I've used 2 marks, I can't use that, I need to use 3 marks. All right? So I marked a reflexive side, and then we need to take a look. Do I have one of my postulates or theorems? I had 2 sides. I now have a 3rd side, which means on a quiz or a test, you might be asked, what is your postulate or theorem? We would put side, side, side here. And you might be asked to complete the congruence statement. So if they said triangle M, AH is congruent to triangle what? Make sure you're very careful how you label the other triangle, because the right pieces need to match up. If they started with M, that means we need to start with T. If they go to A, they go along this side to A, they went past the side with 2 marks. I need to go also to A. And then my last point on the other triangle is H. So I needed to decide on my postulate theorem, and I had to complete my congruence statement. So Let's see if we can use those procedures again on a new example. Here we go. Still have my procedures. Here is example number 2. Let's look at this. I went a little bit far. So I'm used to doing that because I'm usually on my whiteboard and I can erase some of this stuff. But let's throw some letters on there. Let's say maybe we were given that this side is congruent to this one and this side is congruent to this one. We're going to try and find out our postulate or theorem. And if we do, we're going to want to complete our congruence statement. Well, if we go through the procedure again, we should be able to figure this out. First, what is currently congruent? In each triangle, again, I happen to have 2 sides that are marked congruent. Should anything else be marked congruent? Do I have any reflexive sides? Trying to remember, reflexive sides, that's when we have 2 triangles sharing a side. If that's going on, we can mark it. None of these triangles are actually sharing a side. The other thing you need to be ready to look for, we've studied this a whole bunch, vertical angles. Vertical angles happen whenever we have intersecting lines. The angles across from each other have to be the same. We have that going on here. Angle ORF right here must be the same as angle CRE. That gets me an angle. Is the angle, the included angle, is it in between the 2 sides? Certainly is. Which means I should know my postulate or theorem now. I would put SAS here. And I need to complete my congruence statement. If they start with F, I should start with E. Their next letter is O, F, O. That means I need to go E this way to C. And the last letter is R. This procedure will work for every shortcut. We've taken a look at 2 of them. And if you study this and have that procedure handy, I think you'll be just fine.